In this session, we'll be discussing about another flavor of priority CPU scheduling, which is nothing but priority. So what is a priority? Priority is nothing but, so it may create interruptions. Highest priority jobs get executed than the lowest priority jobs. So there may be one more column is needed along with the process ID, arrival time and burst time. That is nothing but priority. So priority, highest number gets highest priority always. And there are two flavors in this. One is a non-preemptive nature, the other one preemptive nature. First we will see non-preemptive nature. We know what is the meaning of non-preemptive nature. Once the process is sent to CPU, that will not be suspended or paused by anybody else. So it has to release its resources voluntarily. That is an idea. So let us see. One more important point, if at all priorities are same, then you need to look at a what? To resolve the conflict, you need to use a what? Arrival time. So what is the meaning of this? If at all process P1 and process P2, it is arrived at time 0, it is arrived at time 1, its priority is, now we has to give a one more column by name called priority. So this is arrival time. This is your process ID. If at all both having a priority 5 and 5, to resolve this conflict, you need to take a what? Lowest arrival time job. So let us through example. So this is the priority order you can measure. What is that? How the operating system is measured the priority of the job. How it knows that this is having highest number and this is having the lowest number. So let us say whenever a process has created by OS, if at all it is a system programs or operating related program, then it is given high priority. If it is a user process, then it is given a low priority. In user process also two varieties. If it is a highly interactive applications like social media, it is giving a high priority. If non-interactive applications, they will be given a low priority. In that low priority, foreground jobs will be given a high priority and background jobs will be given low priority. Okay, this is the priority order how operating systems follows. So what are the advantages in this? So FCFS, there is a convoy effect. SJF, there is a starvation to longer jobs. LJF, there is a starvation to shorter jobs because longer jobs given a priority than the shorter jobs. So priority is going to give you preference to interactive applications like social media. So disadvantages, so starvation to lower priority jobs, and there is a chance of what? Aging problem. So increasing the priority level regularly is nothing but a what? Aging. So what is the advantage with the aging? For example, so there is a process P1 and process P2. Its priority is something like 10. Its priority is something like 5. And there is a one more process is there P3. Its priority is a 9. In this case, first P1 will be executed, then P3 will be executed. Later, it given a chance to P2. So what aging will do instead? So to solve the problem of starvation, every time whenever one process get executed, its priority will be increased. Whenever this process get executed, then its priority will be increased. If at all one more process has come, something like 6, then this process will be given a chance because it is weighted. So what is the meaning of aging? To resolve the starvation problem, actually in this order, if you look at P1 to be executed, P3 to be executed, P4 to be executed, no. Because you are using a concept of what? Aging, it starts whenever a process gets executed, the age of the process is increased. That is nothing but priority get what? So first let us discuss about non-preemptive priority. As I told you, there is a requirement of process ID and arrival time and burst time. There is a need of one more additional column, nothing but priority. Highest number gets highest priority, as I told you. As usually, don't forget our first principle. What is our first principle? At arrival time 0, how many processes have come? In this case, all the 5 processes have come. All the 5 processes have come. So among these 5 processes, you need to cross check which is having highest priority. So this guy is having highest priority. P4 will be given a chance. So P4 is executed 6 units of time. Then it releases all the resources. Then rest of the process are P2 and P1 and P3 and P5. Among these processes, already this is completed, right? Among these, which is having highest priority? 5. So therefore, highest number gets highest priority. Therefore, P5 is executed. It is executed for 2 units of time. By 8, it completed. So P4 got completed at 6 and P5 got completed at 8. Now the rest of the process is P1 and P2 and P3. Among these three, which is having highest burst time, highest priority, so P1 has got highest priority. So P1 is executed for 4 units of time and by 12 it also got completed. And the rest of the process in the ready queue is a P2 and P3. This is having the highest burst time. So P2 is executed for 3 units of time. So at 15, this is also got completed. There is only one process left, that is P3. You need not check anything else. Directly you can execute, and which is needed 3 units of time. By 18, it get completed. So this is how to evaluate priority scheduling algorithm. This is how operating system does. So you do the rest of the work, turnaround time and waiting time. Let's go to another example. This is a different one. So at arrival time 0, no other process has come except P1. Please observe, this is a very, very important problem. No other process have come because they are coming at different regular intervals. Only one process is there in your ready queue, so that you need to pass it. Though it is having a lower priority, it doesn't mind. You have to execute it because no other process is there. So this is executed for 4 units of time and it finishes its task. It finished its task. So there is no P1 now. So during execution, this P1, there are other processes also have come. Who have come? This guy and this guy and this guy and this guy. 4 processes have come. So P2 is there and P3 is there and P4 is there and P5 is there. So among these 4, which is having highest priority? Among these 4, which is having highest priority? This guy. So therefore, P3 is executed for how many units of time? 1 unit of time. So 5 it completed. And what other processes are there? P2 is left and P4 is left and P5 is left. At during of this time, one more process have come, that is nothing but P6, because duration of 5, execution of P3 and P1, one more has come, that is nothing but process 6. So just now 2 processes have completed, and among these 4 processes you need to cross check which is having highest priority. After 7, which is having highest priority? This guy. So process 6 is executed 6 units of time. So it completed at 11 and P3 completed at 5. Right? And what the rest of the process is there? P2 is there, P4 is there, P5 is there. So among these 3, which is having a highest priority after 6, this is having highest priority. It executed for 5 units of time. So P2 is executed for 5 units of time, 16 it got completed. And P4 and P5 is there. Now, among these 2, which is having a highest priority, P4 and P5, P4 and P5, this is having highest priority. So P4 is executed. Then after that, P5 is executed. It executed for 2 units of time. Then it executed for 3 units of time. So P2 is completed at 16. So this is how to solve what? priority scheduling algorithm. If at all priorities are same, then you need to look at what? Arrival time, lowest arrival time process to resolve that particular conflict.